Okay, you're probably studying this video right now trying to figure out what this is about. Especially when you look at this small plastic bottle of seasoning. And you're probably asking yourself, how does this fit into the equation? Let me walk you through it. A few weeks back when I was doing some testing with my DATs, looking at speaker impedance, I knew there was another way to measure impedance, but I'd never really taken the time to build a small, simple circuit to allow me to do so. So there's a lot of folks out there probably watching this that already know how to do this, but for those that don't, I'll do my best to explain it and show you just a small, simple circuit that I put together, again, using a seasoning bottle here. And if my wife's watching, I promise it was empty when I grabbed it out of the cabinet this morning. Or it was when I got it out to the shop anyway. The only thing that you really need to know to measure input impedance is measuring the AC currents and the voltages. So that's exactly what we're doing. I have a fixed resistor in here of 100 ohms. And we can use that along with a signal source and calculate the current, of course, and the voltage. And we can use that to calculate the true impedance of the voice coil across different frequencies. Again, I'm using my iPhone here, and I'm just driving it from one of the programs that I have installed. So this morning I took time to graph out or capture the data from 20 Hertz up to 200 Hertz using this method and procedure, and I compared that against my DATs unit. So let me show you the difference in the results and just show you something that might come in handy out there for folks that really want to understand the impedance and take the time to graph or chart that out. Alright, let me show you how it works. You can see I have my signal source again set at 200 Hertz. Again, typically this would be a little over 1 volt of signal coming through here, AC. This is under load through the resistor in series plus the voice coil. So you can see it's slightly less than that. So all you do is note this number, 0.981, I believe it is, for my angle. Then I flip the switch. Then we look at the results, or the voltage, on the other side of the resistor in series that I just talked about. And we take note of this number. So now we have the resistance, we know the two voltages, we can subtract one from the other, and let me walk you through the rest of the math on how to calculate the current, which will allow us to calculate the impedance of the speaker at 200 Hertz. Okay, here's a look at the spreadsheet. So here's what's fixed again. You can look at R, or the resistor of 100 ohms. Again, that's the value I chose that worked really, really well with a 1 volt input source. But what's important to note really are V1 and V2. So a moment ago you saw where I flipped the switch. So again, with the resistor in series but not measuring on the output side but the input side, that is your voltage reading for V1. So in this case you can see it was 0.9380 for 10 Hertz. Flip the switch, V2, 0.0280. So next all I'm doing is subtracting V1 minus V2, and you can see the difference there at 0.9100. Up next, to calculate the current in amps, you take the 0.9100, divide it by the resistor of 100 ohms. And again, that gives you the 0.0091 amps of current. Then next, you take V2, which was your lower voltage reading, take that number, divide it by the amps, and it will give you the impedance in ohms. So you can see I've got the formula built where you just plug in the two numbers and then you get a really nice graph of the impedance response across the 200 hertz spectrum. Okay, here's that look at the DAT's sweep response for impedance. And again, we'll focus here at 100 hertz. And you can see the big peak in impedance. So just north of 20 ohms. Let me zoom in just a bit here if I can. And you can see that it closely mirrors the results that we actually got by using the impedance tester. So let's take a look at the circuit now, and we'll wrap things up. Okay, the circuit that I mentioned again, the input source that we were looking at again, that I've been feeding that roughly 1 volt signal from my iPhone. Again, I'm pulling everything off the left channel and feeding that toward the 100 ohm resistor here and the single pole double throw switch. Okay, the two voltage measurements I was referring to are V1 and V2, with V1 being on this side of the resistor and V2 being on this side of the resistor. Other than that, the circuit is straightforward. So I hope this added value for folks out there that had not run across this before. Hopefully it will help you if you're into measuring the input impedance of a device using this method and procedure. Thanks again for watching and subscribing to my channel. Take care.